In this video, we solve problem 3 of Unit 13. In this problem, we have a proton. If you go to any text on general physics, you can easily see that for a proton, its charge is equal to the one of the electron. This is 1.602 times 10 to the minus 19 coulombs. And its mass, the mass of the proton, is equal to 1.67 times 10 to the minus 27 kilograms. Okay, so we have this proton that is accelerated from rest due to a potential difference of 2 megavolts. This is 2 times 10 to the 6 volts. And it enters a region with a uniform magnetic field of 0.2 teslas in a direction that is perpendicular to this magnetic field. Okay, so we know that if the velocity, the direction is perpendicular to the magnetic field, then the force, the magnetic force, as it is Q times the cross product of the velocity and the magnetic field, its magnitude is going to be equal to Q times the velocity, the speed, times the magnitude of the magnetic field, because they're both perpendicular. So the first thing they ask us to do is to find its speed. So we don't know the speed of the particle, and we have to determine it from the data of the problem. And this is not very difficult if you realize that they are giving us the potential difference that which we use to accelerate the proton. So the idea is that once you have accelerated this proton, because you have changed the potential energy into kinetic energy. So the change of potential energy is going to convert into the kinetic energy, and this potential energy is going to be the charge of the particle times the potential difference. So from here you see that Q times the potential difference is going to be equal to 1/2 times the mass times the square of the speed. So from here you have that the speed is going to be the square root of twice the charge of the proton times the potential difference divided by the mass, and everything squared. The square root of that. So if you do this and you are careful with the units, so you have all the units here, this is going to be equal to 2.0 times 10 to the 7 meters per second. Okay. The other thing that we ask is the radius of its orbit. So we know that once it enters, it's going to go through a circular orbit, because it's going to move in a uniform circular motion. So the radius of this orbit, we can get it from our knowledge of what happens when a charged particle enters a region of with a uniform magnetic field in a direction perpendicular to this magnetic field. And this radius, if you go back to the slides, is equal to the mass of the particle times its speed divided by its charge and the magnetic field applied perpendicular. So we have all the data we need. We know the mass of the proton, we know the charge of the proton, and we just found out the speed of the proton. And the magnetic field is 0.2 Tesla. So if you do this, you can find that this is 1.0 meters. Okay, and the last part is the orbital period, what we call the cyclotron period. So for this cyclotron period, you can go again to the slides and you see that this is 2 pi times the mass of the particle, in this case the proton, divided by the charge of the proton and the magnetic field. We have everything we need here. We have all the magnitudes, so you just have to calculate, and you can see that this is 3.28 times 10 to the minus 7 seconds.